So we're going to talk about 8.6 and some other things as we get ready for the SAT test next week. So just going to recover just three little topics. Some you have heard of, maybe all of you have heard of it. It just depends on your math background. So today's goal is I can use the cross product to solve. I can also use trig, long division, and radians. That's also our secondary goal there. So our primary goal is the cross multiplication. So here is our problem there. Excuse me there. So when we have a fraction and a number, in order to cross multiply, we need two things. So just make sure you understand. Everyone understands. You need an equal sign. That's one thing we need, and we need two fractions. Okay. So in order to cross multiply, we need an equal sign and two fractions. So what we're going to do here is we're going to put a 1 underneath that 4, so now we have two fractions. Then we're going to cross multiply. So this x minus 1 is going to go to this 4, so it's going to distribute. So we're going to get 4x minus 4. Then that 1 is going to go to the other side, and it's going to distribute. Because we have one thing going into 2, so it's going to distribute, so we're going to get x plus 9. And then from here, we're just going to use basic solving techniques. So I'm going to add 4 over, so I get 4x is equal to x plus 13. Then I'm going to subtract x and get 3x is equal to 13. Divide off the 3, so x is equal to 13 over 3. Okay? All right. Any questions? Oh, well, yes, if you have questions, you have to go back and watch it. That's it, though, cross multiplication. Same thing here. We're going to cross multiply here, so we're going to do this side in red, I think. So x times 18 is 18x. And then we're going to cross multiply there. So we got a distribute here. So 6 times x is 6x. 6 times 2 is 12. We're going to subtract the 6x over. So we get 12x equal to 12. Divide off the 12, get x equal to 1. Again, there are possible extraneous solutions here because we can't have zeros in the denominator. This will work, but if I had like x equals 0 for this problem, I couldn't use it because I'd get a 0 in there. So make sure you always just double check that mentally that it'll work. Like this one's going to work because it's a minus 1 and this is 13 over 3, so there's going to be no 0 there, so we're good. Last one here again, it's going to kind of step it up here. We'll do this one first. So that's going to be a distribute. Okay, so we get 4x plus 20. And then here we're going to go to these two. And now notice we have x plus 1, x minus 1 going together. So that's going to be a FOIL. Because we have x plus 1 times x minus 1, that is a FOIL. Okay, so make sure you understand you know how to FOIL your problems. Okay, those are going to cancel in the middle. So after we FOIL, the answer is going to be x squared minus 1. From here, we need to get everything to one side. And when we have this x squared here, that means we're going to have to do a tic-tac-toe or the quadratic formula. Do you remember your quadratic formula? Okay, so that may be a requirement on the SAT, so make sure you understand when to use those. So we have x squared, we're solving. So I'm going to subtract the 4x over and subtract the 20 over. So those are going to cancel. So we get 0 is equal to x squared minus 4x minus 21. And from here we're going to tic-tac-toe or quadratic formula, whichever way you like. It's going to be negative 7 and positive 3. We're going to times across and add up. It will give us that negative 4x that we need. So x minus 7 and x plus 3 are the answers for the factorization. So we need to solve these, so we'll end up switching them opposites to get the answer. Now notice 7 and -3 are the solutions. When I put 7 in, it'll work for both because there's no zeros in the denominator. When I put -3 in, it'll work for both because there are no zeros in the denominator. So this will work. Again, back to the complexity of problems. At first, we're just cross-multiplying, distributing. Here, we're doing the same thing, cross-multiplication with distribution. However, we're foiling now. When we foil, that means we're going to need to use a quadratic formula or a tic-tac-toe to get our answer. Next, this goes kind of with what we're doing. We have an expression here. There's no equal sign, and we want to find an equivalence or something that's equivalent depending on what's being asked on our questions. And so I want to just cover a long division real quick. Okay, so the number on bottom goes in your box, and the number on top goes up here. Then you're going to match these here. You got to match those. So what times x gives me x? And it's 1. That's going to go there, so we match those. Then we take this number and distribute it. So we get x plus 6 minus. Okay, notice the minus. That's going to cancel those, and I get 8 minus 6 is 2. Now notice I cannot match anymore, so this is my remainder. And so we write the remainder of what we have over what we divided. So the answer is 1 plus 2 over x plus 6. Okay, so that kind of goes along with what we're doing because we get answers that look like this, and you're like, Ms. Chell, can we go any farther? Technically, we can go a little bit farther. Most of the time, though, we never do. We can go farther by using long division. And so notice how that is. Now go ahead and watch that again if you need it. I'll also do another long division problem underneath. The reason why I decided to do long division is, one, it is actually a standard with this unit. So I just wanted to hit it real quick. That means we may have it on a quiz or a test just briefly again, just to make sure we hit that standard solid. So again, the denominator is going to go in the box, and the number on the upside, or numerator, is going to go outside. And we're going to match these. Okay, just remember we're matching this in green. That's what we're matching. It needs another power of x. Okay, so when I distribute it, I get a squared, but I have to do the -1 as well. We subtract. Don't forget 2 negatives make a positive. Then we match again. Okay, I'm going to highlight that in yellow, or green, sorry. I'm going to match again. So I get, I need a 7 to get 7x. This 7 also has to go to the 1 and the x, so we're going to get -7. Don't forget 2 negatives make a positive, those cancel. So 4 minus -7 is 11, and that's the remainder. So we have 11 over x minus 1. So the final answer is that, and that's a 1. Okay? So again, make sure you watch that a few times if you need any help with it. Just kind of recapping long division. It's something I saw on 4 practiced SAT tests last week. So I figured if I saw it on 4 different practice tests, it's a good thing to cover again. All right, so another thing I've been seeing a little bit of is trigonometry. Now, trigonometry, I'm just going to review it. If you don't know it, maybe you have to come and get me some more help, but I just want to review it real quick. Now, I use the acronym SO, CA, TOA, meaning that sine of B or C or whatever, sine of a letter, is equal to O over H, or opposite over hypotenuse. That's what the O and H mean. Cosine of a letter, of any letter, is the adjacent. That's why it's A over the hypotenuse. And then the tangent of some letter is the opposite over the adjacent. That's where the O and A come in. So the SOCA, TOA mean the same thing. Now, remember, we always have to start with the letter. So let's go ahead and walk us through these. So here is B, here is B, and this is going to be opposite over the hypotenuse. Okay? So the opposite of b is all the way over here, okay? And so I'm just going to give this some values here. So let's give this a 6, an 8, and a 10. All right. So the opposite of b would be 6, and then the hypotenuse is the longest side. So if you need to make a note of that, the hypotenuse is longest side. Okay, always. So then that would be 10. Okay, and that's it. That's how you find just a sine b or cosine c or tangent c. So we're going to do the same thing with cosine. So I need to erase all this. Okay, erase my highlight. Okay, we got the cosine of b. Here's b. Okay, that's 10. And then the cosine is the adjacent over the hypotenuse. So the adjacent side is the one right next to it, and the hypotenuse is the longest side. So adjacent would be 8 over 10. Erase that. Now we're going to do tangent of c. So here's c. This is where it gets tricky. Okay, there's c. And notice everything's going to change now because the opposite, so a tangent is opposite over adjacent. So the opposite of c is 8, and the adjacent is 6. So this would be 8 over 6. Now notice the opposite is 8 for c, but for b it's not. So notice it changes. And then that's just kind of how to kind of set it up. If you need more practice with this, that's fine. Go ahead and look it up on Khan Academy or YouTube. There's a lot more in-detailed videos. This is just a kind of a little quick recap. So finally, we're going to talk about degrees and radians and degrees. This is a topic that most students either pick up in like 30 seconds or some will struggle with it for a while. It just kind of depends on your math background. But let's just talk about this. So if I have a whole circle, that is 360 degrees, right, in a whole circle. Now, that makes no sense. I'm sorry, it makes no sense. Somebody decided, how many little tick marks do we want in a whole circle? Let's do 360. You could thank the Babylonians for that, but that makes no sense. And so some mathematicians decided to actually make something up that made sense. So we have a circle here, okay, and it is a distance of 1. And they measure it as a circumference. So here's our circumference formula. Now when the distance is 1, then our circumference is 2 pi, because you just put a 1 in for r. 1 times that is 2 pi. So what happened now is they said, well, let's just call that a measurement. So they say that all the way around a circle is 2 pi because of the circumference formula 2 pi r. It's an easy way to remember it. Okay, so what they're saying is 360 degrees is equal to 2 pi. That's what they're saying. And so radians is another way of measuring rotation. So if I have 180 degrees, which is half of 360, then I just cut this in half, so I just half it. So 180 degrees is pi. Okay, there is a formula for this, and to find the radians from degrees, it is simply multiplying it by 180 over, or sorry, pi over 180. Okay, and then reducing. So this would be 90 pi over 180, which reduces to 1/2 pi, and that's the radians. Same thing here, we just multiply by pi over 180, we get 125 pi over 180, which can reduce to 25/36 pi. And then if we want to go backwards, we just kind of do the same thing. We just do 180 over pi. And that'll change it back to degrees. So the pi's are going to cancel. We get 360 over 120, or over 3. Sorry, I'm doing math in my head. And the answer is 120. So just remember, 2/3 pi is 120 degrees. And we can do the same thing for the last one. I'm going to run out of time. I just want to emphasize that if you know 360 degrees is 2 pi, then you can just cut it up any way you want. So if I want 90 degrees, if I want 90 degrees, I can just divide it by 4, and get 90 degrees. So Have a good day. Bye.